So let me introduce our experts from our panel. I would like to introduce Thomas Wolf, who is a lead of the research team in HuggingFace. Maybe I think everybody knows him because, but maybe not him, but PyTorch Transformers library everybody knows. Then Braden, who works, I think, in Stanford, yeah, and he is one of the core developer of Storkel library, which is now on the third place in Superglue benchmark. On the third place on Superglue benchmark, and Maksym Bevza, who works in Grammarly, Shift.ai, yes, and Grammarly, you know, it's a well-known grammar spell checker for English. So let's start with the first question to our experts, and the first one will be like, what do you think about the recent, I mean, not recent, it's last year, progress in NLP, and what was the most surprising thing in this like big period of time? What was the most surprising for you of the recent progress? You can answer step by step, and know maybe Braden will be the first, and then Thomas and Maksym.
Sure. Is this on all right? Can you hear me? We're good? OK. How's that? That's better. Yeah, what was most surprising to me that happened in NLP this past year? I think it's been over a year since we started with the pre-trained revolution, I guess, in NLP with Elmo and BERT and the other models. I think what was most surprising to me is just that the march has continued, that we continue to see bigger models, more data, and still seeing performance improvements. I don't think that's necessarily the direction we want to keep going, because at some point it becomes untenable for real use cases, for production use cases, and that's where work like DistillBERT and others come into play. But I find it very interesting, just from a academic standpoint, of just how big of a model and just how much data will still provide a little more lift. It's neat to see, I guess, that there's still some wiggle room there. Mm-hmm.
Yeah, I think. I mean, the last 2 years have been just really crazy. I remember 3 years ago when we were in NLP, it was like a bit the boring part of machine learning, and right now it's just the hottest part, I think, and the most exciting. So all these transfer learning models, so we've applied them for natural language understanding, but also now for generation, and we're just discovering that we can do crazy, crazy stuff about them. So I still think there's going to be at least 2 years amazing, like just new discovery. Oh, this can also be done by using this. And I think overall it makes a lot of sense that we can gather all these data sets together, do more multitasking, do pre-training. All this just is basically what we were waiting for. And right now it starts to work, so it's really exciting. And one of the most exciting thing for me in the future is like multimodal, like mixing vision, going behind text to more, other form of data. So yeah.
Yeah, I also agree that like a lot of current pre-trained models like BERT and Elmo and many more already was kind of revolutionizing within NLP, and it was like kind of really inspiring for me to see how each of them can be used for the tasks that have been previously like not very feasible to solve with deep learning, but now we can think about them using like BERT and other models to solve some tasks which are actually like not too much data, don't have too much data, and now all the research community start to think about, okay, like we now have so much of NLP tasks that we have never had so much progress on that, and then now we can think about them again and also find what are the other tasks we can solve using these models. So like the broad of the new emerging tasks that we can use, that we can solve with our current models at the moment, is something that kind of revolutionizing for me.
Mm-hmm. And for me, it's like plus 6% on each task, just pre-trained model, and you'll get 6% or even more on each task when you use new models, new sort of models. So, and the continues this question, should we forget about old approaches and just use transformer models or some like other sort of approaches, or we just maybe use RNNs and CNNs for like some cases?
Yeah, I think it's a good question. I think it's still really a healthy approach to start by simple models, to start by pre-trained embedding, averaging them as a first step, and you get a good baseline because you can go really far. For instance, when you do sentence similarity, when you try to match two sentences in your corpus, like having a good old just averaging of Glovey is still really powerful, and it's really so simple to do that you should really start with this. A lot of people jump on BERT and are like, oh, it doesn't really work for my similarity task. Well, yeah, it doesn't work for your similarity task. BERT is kind of bad at similarity task if you don't have a good data set to fine-tune it on. So yeah, I think we really shouldn't forget about these models. And also because in terms of parameters and like inference, it's really still quite heavy. So we do a lot of work at HuggingFace trying to make this model more efficient, distill them in smaller models so they can kind of work on CPU in production. But this is still quite early. I mean, it's really still early work, basically just 2 months since people have started to work on that. So I think maybe in the future you will have small models that would work well in a lot of conditions, but right now it's better to start with like simple thing, and then you try BERT and you see if it's better. Yeah.
Maybe something to add to Thomas' words.
Yeah, I can just add one more thing. So within my practice, I actually had some experiments which showed that like not forgetting about our old LSTMs and CNN, but actually combining them and then working together with these pre-trained models like Transformer and adding like something like LSTM of top of Transformer sometimes can have unsurprisingly good results. So like old plain knowledge that we had still kind of relevant for us. We shouldn't forget about that, and also this autoregressivity that LSTM has that we try to like kind of remove within Transformer models now come up into play again into some models like AlexNet, for example. So, yeah.
Yeah, just had I think it's a very good point. That it's still not really clear at that point what inductive bias we get in LSTM, what we get in transformers, and so it's still not clear that like transformers are better than LSTM for every task, and we definitely had some inductive bias built in this autoregressive thing that are really good for some tasks. So combining the two is interesting, but also just sometimes using a good old LSTM. And you also have like this open sequence length. You're not constrained to this pre-designed like max length of sentence, which is bothering for many people. So yeah, don't forget about LSTM. But still, use transformers if you can. They're faster.
And the next question about like continued team of SOTA approaches. What is your tips for pre-training models, how to fine-tune them and to reach the maximum accuracy for your tasks? What are, I think, main 3 tips from all of you, what to pay attention to for, and maybe some process?
I know just in competing on the glue and superglue benchmarks, one of the tidbits that we found was that it often was beneficial to fine-tune multiple times on increasingly relevant data sets. So you'd begin by doing multitask learning on all 9 tasks, and then you would fine-tune on maybe just one of them that was most similar to your task, and then finish by fine-tuning on just the one data set by itself. I think ultimately, in the long run, this is suboptimal, and ideally there'd be some sort of smooth gradient as opposed to train once and then train it again and then train again. But for now, I mean, that seems to be the case, that you can almost always improve by fine-tuning at the end on just the task that you care about, but there often is some middle ground that'll get you closer than just the general language understanding that you get with like a BERT model. So some other intermediate data set can often get you even closer before you use your precious few hundred examples or whatever you have for your specific task you care about.
Yeah, I agree a lot. I think still when you have a very small data set, it's always a bit tricky to use these models. One of the main reasons, in my opinion, is that they're very fast learner and they grab surface form things. So for instance, if you have annotation artifact, like, I don't know, most of your positive sentence don't have the word not or something like that, the model will quickly grab this thing that if there is a not, it's positive. Like quickly grab this just surface form information. And if you have a small data set, it's usually more prevalent, this kind of thing. And then your model doesn't really generalize because it's really stuck to your data set. So that's one of the issues. They are just too powerful, and usually they grab these hints that we don't want them to grab, like vocabulary hints that we don't really want them to grab. So if you can have a bigger data set for fine-tuning also, it's very good. One good example recently on Glue is the WNLI task, which is a common sense task. One example is the trophy didn't fit in the case because it was too big, and you have to guess if it is the trophy or the case. And the way people really get huge improvement on this was to actually rule-based creating a data set that looks the same and train a model on this huge data set that is like intermediary. So if you have your target task and you have a way to find a big data set that's kind of related to the one you want at the end, or to build one automatically with some smart heuristics like snorkel kind of thing, it will obviously help your model to be better. So yeah, don't forget to get big data sets.
One other thing I might add, I guess, and we'll hand it over, is it's not always just a question of size to pre-train on the big one and then fine-tune on the small one. It's often also a question of task difficulty. Even if you have a very large data set, if that task is simpler than the one that you care about, I've found also that pre-training on a simple but large task will often still result in a worse job than you would have had if you just had trained on the harder task. And I think it comes back to those simpler surface forms that Thomas mentioned, that on the simple task, it'll learn just what it needs to get the simple task right, and that ends up making not great building blocks for a more complex task. And that's part of the reason why language modeling is such a powerful pre-training task, because you have to understand so many different things to guess the next word in a sentence, including co-reference and gender and general syntax and whatnot. So in general, it's harder than most tasks, and that's why it works so well. So one thing to be, I guess, wary of if you're pre-training and fine-tuning is you want to be moving, I guess, to simpler and simpler tasks as you fine-tune, in general.
Maksym, something to add?
No, I think it's good.
Maybe I want to add that maybe Thomas and Braden and Maksym will correct me, but now the setback shows us that we can, from unsupervised dataset, we can create a supervised dataset, like a next sentence prediction or just a mask word prediction, and we can generate many tasks on supervised dataset, and on this way we can create like a more powerful model for pre-training and then fine-tune it on our task. So we can just use unsupervised data and create from this supervised data and model train.
Yeah, I think it's a good point, yeah. Usually we often call that self-supervision because it's not really unsupervised. It's kind of a trick to build supervision from just the data. Yeah, that's the way we're going, and it's also super exciting to develop new things. Like SpanBERT is a good example also of improving. Instead of just predicting one word, you predict a span, and it's obviously harder, so it goes in the right direction as a pre-training task, and it's not too hard, because if your pre-training task is too hard, then your model just doesn't really manage. But yeah, there are a lot of cool stuff coming on in this field, in this area.
Yes, and but there is a question of this like best SOTA models, that when we go deeper and we see that on Glue benchmarks SOTA results are better from our models than human results. But last research was shown that it is not true. Models just overfitted on this data set. They overfitted on some n-grams, and on this way they beat human on this benchmark. So the question for you, what we should do to generalize our models, that we will not just learn some n-grams, but it will think in a different way and could generalize their knowledge and do tasks more wisely than just learn some stuff like, this effect of clever hands, clever guns, when there was a horse which could tell something when people give him some mark. So what do you think about this stuff?
Yeah, I think Braden probably has cool stuff to say, but I think Clever Hunts is a very good example. Actually, just before the bird craziness, we were trying to build some library that would generate adversarial example in NLP. So adversarial example is when you try to find an example where your model fails, and you use that to make it better. So for instance, you take a sentence that works well, and you change a word by a synonym, and then your model is lost suddenly. And this is a cool thing, because if you can generate this example at scale, and you put them in a training data set, your model is better. So I still think like this approach of adversarial training would be super interesting for transfer learning, also because we have small data sets, so that would help us like make more data. So I think this is the direction we will go probably, and you can kind of incorporate your knowledge of where the model is failing at this stage. So I think this is a good direction. And then the other part is what we've discussed earlier, which is basically that this model fail in ways that are usually unexpected because they learn this shortcut in the data set that you don't want. But yeah, it's all related. And so transfer learning helped a lot for that. But yeah, adversarial learning is something...
So you see the main progress in adversarial training? Like
yeah. Like, I think adversarial training during fine-tuning is a direction that we would like to explore, at least at HuggingFace. Yeah.
Yeah, I'd like to add one more point here. So I also think that in addition to what we already have with like all this contextualized embeddings for words and for sentences, that's like really a recent development that we already pursue, and giving even more context and giving even more understanding of what this particular word means within the context is like a promising direction to like building more coherent sentences and building more coherent understanding of what what each word means in the context and what does the author wants to like say in the current sentence. So like I think this emergent field of like understanding the context of each word is the one is something that like can give us like really good results in the future for like building some good models.
Yeah, I've got a few thoughts here. One, just echoing, I guess, what both these guys said on data augmentation or adversarial training. That's something that has become totally necessary if you want to have state-of-the-art results in image processing that everyone does. Often somewhere in their pre-processing, you'll find where they're flipping images, rotating images, things like that. And it's been harder to do in NLP because of the discrete nature of words as opposed to pixels that you can be more comfortable making changes to. But I think we're seeing more progress there, and that will be probably increasingly important for teaching our models invariances that should hold. Like when I change a synonym, you should give it the same class most of the time. So yeah, data augmentation for NLP, I think it will be very important. And then I guess just taking a step higher on the broader question of how do we make sure that we're not that these benchmarks are worth something, and we're not going to be able to pass them with simple n-gram approaches. I think Sam Bowman and his group did a great job on the glue tasks that they provided about a dozen benchmark implementations of by LSTMs and CNNs and bag of words and different things. And that's, I mean, any benchmark data set that someone's going to introduce, I think it's great and responsible to run those first and make sure that there is something here to be learned beyond just exploiting these simple patterns. So that's encouraging to see.
Mm-hmm. And as you know, models like BERT and some other are very heavy, and it's really hard to move them to production and use them there. So HuggingFace was done research nearly as you read about it, about digital BERT, when they reduce size and speed up accuracy 2 times. So what's the next moves to increase the accuracy, not reduce the accuracy, but increase the speed? What the new research will be in the recent time, and would so this is the question. So what the new steps in increasing speed and not decreasing accuracy in the same time?
Yeah, I think one of the first surprising thing here is that we discovered that we can actually compress these models in fairly small models and still get most of the performances. So this is like kind of unexpected, at least for me. When we started this project, I was not really expecting we would keep like 95% of the performance and just divide the parameters budget by 2, which make a big difference. Actually, we're just behind most of the current state-of-the-art model. even LSTM, they're usually famous for being small, but if they start to be bigger than our small transformer, then it really makes no sense to use them anymore. And so I think, yeah, trying to see how small we can go is a very interesting direction. I don't think we'll be able to train these small models from scratch. I don't think it's the way we should go anyway. So this will still be like a two-step process where we have these huge models that have learned all this inductive bias on huge datasets, and then we just try to distill them on a model that is small enough so we can use it in production. So this is like the general area. On this thing, we want to start a competition or shared task trying to push people to get the smallest model possible that get the best performance on Glue. So hopefully, if this thing is accepted, we get a cool competition next year about that. I'm really excited about that. And then there is a lot of work on engineering. Python is slow, well, slow in some conditions. So we also working with the PyTorch team on Torch script, which is a way to convert your model to C++ models that you can also put then on the edge in your mobile easier. So this is also very promising, I think. Quantization is a good way. Obviously, these weights are just we have too much precision. We know that we can just put them from float 32 to float 8 and still work. So this is a good way. TensorFlow is already pretty good on that. PyTorch will join. I have heard in October they will have a lot better support for that. So quantizing is also a good way. So I think in the end there is really promises that we may get really small models that would run on the edge easily. So this is really exciting. And then the last thing is I forgot. I wanted to mention something about TensorFlow, but I forgot.
Well, maybe I'll ask a question to Maksym and Braden. Do you think that creating a benchmark, like in ImageNet, that you need to achieve some accuracy, and then to measure time like this? For example, we need to achieve on Glue benchmarks, for example, 75 score, but for the smallest time. What do you think? Will it increase like research on this field if it will be some challenge based on it?
Yeah, no, good question. I see these benchmarks sort of the same way I see multitask learning, in that I think each one of them is often like our ultimate goal, like our ideal objective would be, get models understanding natural language as well as humans, and none of these benchmarks are perfectly aligned with that, but like they're similar enough that by doing better on them, there's some positive, cosine, I guess, value there that projected back onto our true objective we get to keep. So I think the benchmarks are very valuable in that, humans are very good at making a number go up. If you give us a target number, we will throw everything at it, try new things, shout from the rooftops when we get a new score. Everyone will try that out as well. So there's been great progress from these benchmarks. And I think that most of the progress comes from the initial thrust of trying new things to do well there. And then eventually we do fall into overfitting to that task, and that's no longer productive for the overall goal of do well on general language understanding. But I think they've been invaluable, and we see that with ImageNet or with Glue and SuperGlue and things like this, that there is a net positive, but I don't think we should read too much into when you get to the point of increasing by tenths of a point, we may just be overfitting, and we've seen that happen with past benchmarks as well.
Yeah, I just kind of similar point, but not directly to performance and accuracy of our models. But I've recently seen a really good and positive trend of measuring also different statistics about how much time does it take to train the model, how much time does it take to deploy them, well, not deploy, but measure all of the speed parameters and also the CO2 emissions. That is something that recently people started to calculate, how much CO2 do we produce into the air while training all of these models. So we know that training some models like BERT and Elmo, they are really, really huge, and all of these transformers are all good. However, we already start to kind of concerned about the nature and the amount of impact that we have on the nature just by training our models. So given, I really like those papers and encourage you also to publish your results with that. That also show the performance, the speed, and the time and CO2 emissions that it takes to produce the model and to actually train it and to deploy it to production. So this trend is emerging and also really interesting, and I think it's a positive thing in our research culture.
If I don't mistake, Roberta was trained on 1,000 GPUs for 7 days. So let's go to reproduce it. Okay, we have like good models, but now we want to speak about data, and maybe especially for Braden this question, because his library is specialized on data augmentation. So what is better now, to have more data, but which is less precise, but we should have less data, but it should be more precise? What do you think, and what some concerns about it?
Yeah. I want both. I want lots of data that's clean, but if I can't have that, I mean, I think there's a place for both. I think often you can, weekly supervise or in a self-supervised way generate that large data set that's related, but maybe not perfect, but will get you a lot of the way there from random initialization to pretty close to your task, and then you can fine-tune on that most clean data that you have. I think it comes on a spectrum, and often there is a spot for some small bit of extra clean, data for the last minute fine tuning. But in general, though, I'd say, I mean, the architectures have gotten so good, but they are quite data hungry. So pre-training is one way to reduce the cost there. But in general, I'd say most applications are underutilizing weak supervision, underutilizing focusing on the data. That there is often a lot you can do. Sometimes it's the data augmentation stuff, like we mentioned before. Sometimes it's baking in other invariances, like using synonyms or whatnot, and that again falls under data augmentation. And sometimes it's finding a close enough task to pre-train on. But definitely for most new applications where you're not tackling a benchmark task like ImageNet or something, it's the data that's the bottleneck for you. So they're more focused on techniques for generating training sets or heuristically labeling or whatnot, I think is a very interesting and promising direction, especially for the one-off tasks, far more so than for benchmarks. Though it is interesting noting in like the glue and super glues, some of those tasks did finally see the most lift when people started creating auxiliary training sets to train them on, like the WSC task or WIC or ones like that.
So, as I understand, you mentioned that we need, it's better to have less data but more accurate and pre-train these models on some other tasks. And it will be better.
Yeah, it'll depend on the particular task and the particular values we're talking about here. But I mean, certainly 100,000 noisy data points are usually better than 100 perfect ones. As those numbers get closer, the trade-off changes. But there's often, I think, a lot more that could be done than is currently being done to utilize noisy data in productive ways.
Mm-hmm. Thomas, Maksym, maybe something to add?
No, yeah, I think it's a good point. I think either you can have a very large data set which is a bit noisy, it's okay. But when it's a small data set, I think it's also cool to have a deep look at your data. I remember this shocking paper where they removed the example from translation data set and they get better performance because they remove all these bad examples. So, I mean, taking care of your data is just so important. You have to look into it, to read it, and if you have bad example or bad things, you should really clean them if you can. It's important. Yeah.
So it's better start with clean data and then try to add more, maybe a little bit noisy, but it will help. For example, we should start with clean data, mostly clean data, and then we should go to increase the amount of data, but it could be noisy, but it's okay. Something like this.
Yeah, I think there's probably a sweet balance, a sweet point to find here, because obviously very large, noisy data sets are great, so it's okay if you're in this situation. But when you're in a situation where you're more data, if you can generate a large noisy data set, it's always, I think, better if it's quite good. But if you have small data sets, then having clean data set can be key in some task. Yeah.
Mm-hmm.
Yeah, I'd like to add here. I've recently seen a couple of times already in my practice that even the surprising power of fine-tuning, even on small amounts of data. So after training the model and then getting only a couple of thousands more examples, which are really, really good, cross-annotated and everything, and fine-tuning just on those, help to improve the model, maybe by not a really huge margin. However, there is a shift in a positive direction. So just as Braden said, like we'd like to have both. So if you have some budget to allocate for just like a couple of thousands of more examples, but that are really more qualitative, then well, consider doing that.
And now we are going to like a global market, and company want to have all the features on the different languages, and like XMLnet allows it because it has I think 17 languages. We also tried it in our company. It works great. So what's the next steps in like multi-languages approaches like XMLnet? What do you think? Like what we should expect in future? Something like this question.
Yeah, I think it's quite still an open question. I mean, there is interesting work because one interesting thing about this model, I think, is that they are trained on all these languages at the same time. It's just one model for 17 or 100 language, and they find some way to actually use commonalities or common thing about languages to be better things. So you have a huge effect of data augmentation here, even if it's cross-lingual data augmentation. So I think these models are here to stay, this multilingual. But on the other hand, I would like to see more like language-specific model in language where you have a lot of data. I mean, like, for instance, Russian, Ukrainian, you obviously have enough data to train a good model. So here it's more a problem that like the company training this model are US-based, English-based, and so they mostly focus about English. So that's something we try to push in our library. So now, for instance, we have a German bird, which was trained on German, but I would like to see more models like this, yeah, in other.
That's one of the problem in industry is that everyone does everything in English, and then maybe someone will do it in another language. So how to maybe change the model architecture to help it, maybe because in XMLnet the one improvement was like adding like language embeddings, and that's all. Maybe because it didn't have no like it is the same as BERT, but with no language embedding. Maybe do you have any ideas how to like train it or how to add in architecture which will help to increase accuracy?
Do you mean adapting the architecture to specific languages?
Yes, maybe it should be have more information about what language do we use and what's the like differences in these languages to like for translation or for even classification, something like this.
Yeah, I know there are cool works in this area. Like Caio del Coro is doing really interesting work in this, trying to build a model so that you have invariances, or like, for instance, you have trained this model on English. You know that in some other language you're supposed to switch the adjective or something like that. Can you build this switch in the model architecture? I think it's still an open research question. But yeah, I really would like to see it. But it's not really my field, so I'm not.
What do you think will this theme of work for multi-language will be like on a paper on the main field of research, or will just try to increase everything in English? Do researchers will be interested in like this stuff, or is they just interested in English to beat super glue benchmark?
Yeah, I think it. We should build this benchmark. I think if you let US university, they always end up building English benchmark. But yeah, I think we will see more like cross-lingual. We start to have some interesting benchmark for cross-linguality. But I'm pushing, like, each time I talk with like a French startup, I'm like, why not building the same squad in French? Like, it's not so expensive. Sometimes we have this idea that it's crazy expensive to train a model or to build a data set, but it's doable for most like big enough organization, I think.
For Google, it isn't expensive.
I mean, yeah, they put the numbers, it looks big, but like training GPT-2, for instance, is just 25K in the end, and it's like 1.5 billion. It's not BERT, it's like 5 times bigger. But if you have a few tens of 10K, you can do it. You just need to have the incentive.
And here we go to multitask learning. Maybe every company interested in it. And HuggingFace has a big research in HMTL. And Snorkel has some approaches to do multitask learning. So what do you think about multitask learning, how it helps, and what like the concerns about using this approach? But not only advantages has this approach, but maybe and disadvantages. What can you say about multitask learning?
Yeah, I mean, so I think multitask learning has proven its value in that it's helped a number of tasks to do better. I think it's still, there are, so many of our libraries have been created with single task, I guess, problems in mind. So it's often, you don't have quite the control or visibility that you would like when training a multitask learning model, whether that's tracking different accuracy, like different metrics per task, or like monitoring the progress on all your tasks at once, or balancing that appropriately. So I think some of it comes down to just like the infrastructure not being quite as well supported yet for doing MTL. Like most of the MTL successes have been done in one-off sort of bespoke ways for the problem they're tackling by researchers, rather than as sort of like institutional support within a PyTorch or a TensorFlow. I also think that just in general, I think there is more to be exploited in acknowledging the similarities between transfer learning and multitask learning, that they're really the same thing, just on a spectrum in terms of, you've got, at the end of the day, multiple data sets, multiple tasks, and you're just changing when you freeze certain layers, or when you run which batches through. So again, as I sort of alluded to earlier, I think there is room for finding smoother ways, paying more attention to training schedule to get most of the benefits of multitask learning with a lot of really getting, I guess, the best parts of both worlds. And you can maybe avoid some more of the catastrophic forgetting that you get when you just pre-train and then just fine-tune, but still have some of the specificity that you get when you fine-tune at the end of the day on just the task you care about. I think that could be done more smoothly, and someone just needs to do it, to research it out.
Mm-hmm. I have the problem, like, to find the early stopping at the same time. It's the best, global maximum for each task. It's very hard to synchronize the best moment, the best moment when to stop training. It's like one of the hardest tasks of multitask learning. I saw in HMTL work from by HuggingFace, you used random sampling, and you try to find this sample rate to achieve this global maximum for each task. If I'm right? Am I right?
Yeah. There's since HMTL, there have been some work, some people trying to make automatic way to see what's the optimal for when you combine tasks. Because obviously some tasks will help for other tasks, but sometimes will damage. So you try to find the optimal way to combine them. I think we're making progress on this too. But it's important.
It's last question. It's more like to speak about GPT-2 and they state that they didn't want to publish a large model because it's could be harmful for people, for generating fake news. What's your opinion about this one? Is it a PR move, or it's there's some internal stuff about releasing it, or they really think that it could be harmful for our lives?
I hope they didn't say it from their own experience.
Yeah, I can't speak for the motives, I guess, in the announcement, but as a matter of policy, I think in general the best approach is to put things out in the open. I think open source code tends to be more secure. I think we develop more robust defenses when the attacks are known. The same sort of, I guess, questions you get with general cybersecurity and zero-day attacks, that there are sort of established best patterns there. And I think in general, the best thing to do is to release it and have the world put its collective, I guess, knowledge to work in learning how to defend it.
Yeah, I agree. I think one of the learnings we get since this release is that basically it's quite easy to train GPT-2. Basically, a lot of people have done it since, and it's also not so expensive. So just really doable. So yeah, just releasing seems the right way to go, so people can then use it. But on the other hand, I like the fact that they kind of started a more general discussion about ethics in NLP, which was maybe not as vibrant before. So now people are like, okay, there is a problem with this model. What can it be? And besides the danger, we also kind of emphasize the bias problem and all this kind of thing. That it helps on these things. So this is something I liked about it. Yeah. But then, yeah, overall, I think they could now release it. Now we have a lot of other huge models like this. So.
But we'll hope that many companies will release the models, and HuggingFace team will implement them in their package. So thank you everyone for your attention. You can catch Thomas, Braden, and Maksym in the hall and speak to them privately. So thank you everyone. Thank you.